many of you know someone who is dysfunctional, right? That you would describe as dysfunctional. And then think about why you would describe them as dysfunctional. Right, so we use that as kind of a slang term, like, oh my gosh, they're so dysfunctional. But really, if someone is dysfunctional, I mean, what is it that they're not doing, right? When they're not functioning, right? What does that mean? If you can't function, you can't hold down a job, you can't get things done in school, you can't get through normal life, right? That's what it means to dysfunctional, to be dysfunctional, okay? So if you don't function, if I say like, well, my computer is just not, it's not functioning, right? What that means is it's not working. And so sometimes our math definitions are actually not too far off from real life definitions. Okay, so to be able, when we talk about a function in math, a function, put the word a in front, a function is like a job. That's a pretty good way to describe a function as a job. All right, and then I'm also going to say this about a function. A function describes a situation in which one quantity is determined by another. Okay, so a function is a job. A function does something. Right, it does a job. So maybe we have a function which adds 2 to a number, right? And that function would look like this. It would be like f of x equals x plus 2. And the job of the function is to add 2 to a number, okay? And then one quantity is determined by another. So there's this link between what we put in and what we get out. So if you want to understand functions, you have to understand that the simplest definition of a function is we put in some input and then we get some output. A job is done to that input and then we get output. So the handout here starts with operations with functions and the algebra of functions. And it starts off pretty easy. Right, so there's rules with functions that are summarized on the tables that I give you. Probably the hardest thing in here is determining the domain. So let's take a look at the functions that I gave you in number 1. All right, there's 3 functions. Let's see if you can write down the domain of each of these 3 functions. All right, so pause the video for a minute and let's just list the domain here right up above the function. Okay, so if you're back, the first one is a polynomial, so its domain is the set of all reals, which I could write as negative infinity to positive infinity. I hope you recall that the square root function does this, right? It's only in the first quadrant, which means the domain, I use closed brackets because I can include 0. So 0 to infinity. And then this one, x can be everything other than -2. So like on our number line, the only, or I'm sorry, not -2, +2. So on our number line, the only thing we can't equal is 2. So we would write it in interval notation like this, 2 to infinity, and then -infinity to 2. And I use this U means union. This means together with. This symbol here is known as intersection. All right, the intersection. So if you were by that, the Bronze Bear on Main Street, her name is Emmeline, I believe, and she's a bit of a legend for Geneseo. She's actually 2 different times, or actually at least 2, maybe even 3 times, someone has hit that statue with their car or with their truck. I think it's usually a truck that hits it. But anyway, I hope you have walked around Geneseo enough to know what I'm talking about, that bear statue right in the middle of Geneseo. So anyway, if you're by that bear statue, are you on Main Street or are you on Center Street? Right? And you're on both, right? You're in the intersection, right? That is the intersection of Main and Center Street. So intersection means that you have to be on both streets at that particular moment. So anyway, in carrying out some of these exercises then, when we're asked for the domain is the intersection of both other domains. Okay, so if I can't input 2 for g of x, then anything I do to g, right? Whether I multiply it, add it, divide it, all of those will create a situation where I still can't input 2, okay, because of this. So anyway, the first example, f plus g of x, and state the domain. So what this means is I just have to take f of x, take g of x, and add them together, right? Not very difficult at all, right? So f of g of x is this. And then what is the domain? So I have to intersect the domains of both of these functions. Well, I have to put all reals with the intersection of this domain, right? The only restriction then is the 2. Okay, so in letter A, I still can't have 2 as part of my domain, even though it's a domain of this part of the function. So the domain in letter A would actually be just the same as the domain of g of x. All right, now find h of g of x and state the domain. Okay, again, not very difficult, right? Take h of x, take g of x, and multiply them. And I'm going to write this as like radical x over 1. So then it's just radical x times, I would write it like this to write it in simplest form. That would go in the numerator. And then what is the domain? Okay, I can still input 0. Right, I'd have 0 over -2, that works. And I can't input 2 still. Okay, so my domain would look like this. Start at 0, go to 2 but not include 2, and then union 2 onto infinity. And when it comes to some of these other exercises like h of g of 9, what I could do is I could either find the function h of x divided by gx first and then plug in 9, or I could simply do h of 9 divided by g of 9, right? Whichever is easier. Okay, so I could just plug into each function separately, or I could find h divided by g, which is h, here's h, divided by g. Well, how do I divide by a fraction, right? I flip it. So h divided by g would be this. Right, so this is the function h over g of x, and then I could just plug in the 9 for x, either way. All right, so pause the video and please try these finishing up C through F, and then when you come back, check your answers, and then we will call it a day at this point. Okay, so there's the domain for that. This one, when you plug in 4, probably the easiest way to do it is to just plug in 4 to F, then plug in 4 for H, and get 13. this one should be, so this will be 21 over here. And this one will be 26 times a third, which is totally fine to just leave that as 26 over 3. Nothing wrong with that answer. All right, so 26 over 3 as my final answer for letter 3.